This is Poland for AP Statistics. In this video, I'm going to go over the Chapter 1 review sheet and then specifically going over problems 13 through 15. So for problem number 15, they give you a series of histograms and they want you to identify which one has the smallest standard deviation. In order to do this, you really have to understand what standard deviation is. Standard deviation represents the average distance each data value is from the mean. The closer your data is to the mean, the smaller the standard deviation. The further the data is from the mean, the larger the standard deviation. And if you look at each one of the diagrams, the standard deviation, the mean is going to be about 3. This one may be between 3 and 4, but they're all about, and again, this is slightly skewed, so it's probably somewhere in there. Actually, it is at 3 for all of them. Okay. So how do you get the standard deviation without actually having, or the relative standard deviation values? Because you don't need to know the exact. You just have to identify which is the largest and which is the smallest. So notice that on choice A, okay, with this histogram, you have a lot of data that's far from the mean. How can I tell? At the value of 1, we have a frequency of 4. At the value of 5, we have frequency of 4. At 2, you have 3. At 4, you have 3. And you only have a little at the actual mean of 3. But you have a lot of data values that are far from the mean. Whereas in choice D, again with a mean of 3, you have very little that are at the tails that are far away from the mean. So this has 1, this has 1, this has 4, this has a frequency 4, and this has a frequency of 5. The rest, choice B, C, and D, are going to be values that are in the middle. So choice A is going to have the largest standard deviation of the 5 choices because you have the most data that's furthest from the mean, whereas choice D, you have a lot of data values that are close to the mean of 3. So this is going to have the smallest, and that's why the answer to this problem is going to be choice D. If you're feeling uncomfortable with this, you could try to get an estimate of what the standard deviation of each one of these. I'm going to just show you with choices A and D to save time. And what I'm going to do is I'm going to enter it into the graphing calculator. Again, you do not have to do this. It's just if you're having trouble processing that. So I'm going to open up a new document. It's always a good idea. And I'm going to add in a list in spreadsheets, and I'm going to add in column A and X, and I'm going to type in the data values 1, 2, 3, 4, 5. And I'm just getting that from the values on the x-axis of the histogram. I'm then going to create a frequency column. And I'm going to, I think I estimated the frequencies of already of 4, 1 is 4, 2 is 3, and so forth. And I'm going to enter those values in the calculator. So that was 4, 3, 1, 3, and 4. And then I'm going to hit Control Doc to add a calculator page. I'm then going to calculate the standard deviation by going Menu, Statistics, Stack Calculations. It's one variable, the variable X. It's one list. The frequency list is not the same thing. You're going to enter X for the variable, and instead of 1, you're going to enter. You're either going to hit the drop-down menu, which I'm having trouble with right now, or F. And when I do that, I get a sample standard deviation of 1.59. Just want to check I entered this correct. I made a mistake. This should have been 1. I don't know why I entered 2. So I'm just going to repeat. It's still going to give me the same concept, but that bothered me that I didn't get the same value from before. So menu, 6 for statistics, 1 for stat calculations, 1 for one variable statistics. It's one list. You're going to enter X for the variable name, and for the frequency list name, those frequency values, you're going to enter F. And you still get a mean of 3, but the standard deviation should be 1.65. 1.65, hold on. So let me write that down. And we're going to do the same thing for choice D. Notice we're going to use the same data values, but we're going to change our frequency list. So 1 is 1, 2 is 4, and so forth. So I go to my calculator, go back to 1.1, and I'm going to change this to the other frequencies. So 1, 4, 5, 4, 1. I'm going to go control page, add a calculator page. I'm going to do menu, statistics, stat calculations, one variable statistics, hit OK. I'm going to enter X and F and hit OK. And when I do that, I get a mean of 3, but my standard deviation is 1.07. So you can see that that's smaller. And you could do it for each one of these. I'm not going to do it right now, but the answer is choice D. It's going to be the smallest, and the other values would be in between. Number 14, a medical researcher collects health data from 200 women. And a lot of times people ignore those values. That's the sample size, and that's going to be very pertinent to this problem. One of the variables measured for each woman in the study is her weight in pounds. The following list gives 5-number summary for the weights of the adult women in one of the countries. So these values are not actual data values. This is the 5-number summary. So this is the minimum value. This is quartile 1. This is quartile 2. This is quartile 3. And this is the maximum value. And a lot of times people forget about that. They don't pay attention to that. And you actually need to know that. So the minimum value, we're going to actually plot these values on a number line to create a box plot. So here's my 92. Here's 110. Again, you don't need to do it, but I think it clarifies the concept. This is the median of 120, the quartile 3 of 160, and the maximum value of 240. Now, there may be outliers, but we're not going to take that into account right now because it doesn't help with the question. About how many women, notice they're looking not for a percentage, but about how many women weigh between 110 and 240. Well, 110 to 240 is anything above this line, to the right of that line. Well, this represents 25% of your data. This represents 25% of your data. This represents 25% of your data. So they're looking for 75% of the women in this sample. So 75% of the women in the sample, and we know that the sample size is 200, weigh more than 110 pounds. And so 0.75 times 200 is 150, which is choice D. Okay. Number 15. Mr. Buckley's test scores have the following statistics. So they give you these statistics. Which of the following statements about outliers is true? So they're looking for information about outliers. Okay, so you need to do the outlier test. And remember I said you needed to know that the rules for the outlier test, because you're not going to always be able to stick the data in the calculator and have the calculator output the outlier. This is how they'll present the problem. Okay, so to do the outlier test, you need the lower value, the lower fence. And to get that, you're going to take quartile 1 minus 1.5 times the IQR. So we have to calculate the IQR. And to calculate the IQR, you're going to take quartile 3 minus quartile 1. And when you do that, you get 19.5. So that's something you have to memorize. Oh, the IQR is 19.5. So now we're going to use that. Sorry, I lost my place. So you're going to take 70.5, that's quartile 1, and you're going to subtract 1.5 times 19.5. And when you do that, you get 41.25. And now we want to get the higher fence. And the formula for that is Q3 plus 1.5 times the RQR. And again, you have to memorize that. So quartile 3 is 90 plus 1.5 times 19.5. And that's equal to 119.25. And then you don't have to do it this way, but I find that visually it's easier for people to see. What I do is I put the fences on a number line, and that tells me the bounds. Sorry, the computer is blitzing on me. So anything in between those fences are considered usual, and anything below is a low outlier. And this is going to be a high outlier. And so now we don't have the actual data, but let's take a look. So my minimum value is a 32. So there may be a lot of values in between, but I know there has to be at least one low outlier. And the highest value, the maximum value, is 99. So it doesn't appear that there are any high outliers, but I know there has to be at least one. There could be a couple, but I'm guaranteed that there's at least one. And that's why it's choice B. I think what I have on the SmartBoat book is an old review sheet, but I'll go over this one just in case it's on yours. It says, which of the following statements is true? Histograms have gaps between the bars. That's false. That would be a bar graph. Dot plots do not provide enough information to determine if there's outliers in the data. That's not true because you can actually figure out what the values are and then calculate it. Bar graphs can display both quantitative and categorical data. That's false. Bar graphs can only do categorical. They're trying to confuse that with histograms. Stem plots are the best graphs for displaying data sets with two variables. That's not true. You would use, we haven't done that, that's next unit, scatter plots. Box plots clearly show the 5-number summary of the data. That's a true statement. In any case, I will open up another video in a little bit for the next set of problems.